Well, you all know, you'll see they're very helpful, okay, for us to do the calculations, okay. Section 3.2, okay, I will have to highlight this section, okay. Product rule and quotient rule, okay. So basically, there are only two rules in this section, but they're both important, okay, they're both important. So, we have the product rule here, and we have the quotient rule here, okay. I'm going to ask a volunteer to read both of these two rules for us. You see, that's only new material for us in section 3.2. After we learn the rules, we'll keep on doing differentiation, okay. Now let me see whose turn. Tyler?
The product rule, if f and g are both differentiable, then derivative of f of x times g of x is f of x derivative times g of x derivative plus g of x times f of x derivative. The quotient rule, if f and g are both differentiable, then g of x times f of x derivative, take away f of x times g of x derivative divided by g of x squared.
Very good, thanks, okay. Well, so these two, I copied them from the textbook, okay. They're in the Leibniz notation, okay. D of this dx, d of this dx, okay. I would like to use prime, okay, prime. So if you use prime, okay, I'm going to rewrite the product rule by this. So this is product rule, means if we have a product of two functions, we want to differentiate the product. It is equals to differentiate one of the function. Is if we differentiate f, then we multiply the result by what? The other function g, plus differentiate the function g and times by what? F. So f times by what? G prime. Okay, so this is more easy to understand, right? So the derivative of a product equals, let's pick up each of them to differentiate each of them. But when we differentiate the first one, we multiply by the second one, no change. Okay, yeah, we don't differentiate the second one, okay? And if we differentiate the second function, we multiply the result by what? The first function without the differentiation. Do you see that, guys? Okay, so this is a product rule. If you want to, write down this on the side of your note, that's hopefully help, okay? This is a product rule, okay? Quotient rule is telling us, if we have a quotient of two functions, bless you, on the bottom, okay, we're going to have what? The denominator function g square. Okay. Well, on the top, what do we have? Derivative of f times by what? G. So differentiate the top function at first times by what? G. This order is important, guys, okay? We have to differentiate the top function f and then times by the bottom function g. Then minus what? F times by what? G prime. Or you say differentiate the bottom function and then times by the top function. So the order matters, okay? On the top we do f prime times g minus f times g prime. It's not g prime times f, no, minus f prime g, okay? So you have to be careful about the order, okay? So that's why you can write down this on your formula sheet. So make sure you write down the correct formula and then do the correct calculation. Alright? Alright, so we're going to practice using these rules, okay? Product rule and what? Quotient rule, okay? So we have 4 problems, okay? The first 2 problems, they're about what? Can you see which rule I'm going to use? Product rule or the quotient rule from the first 2 questions? Do you have any entire fraction there? See, this is what? Multiplication, right? And you may say, oh, this is a fraction, this is a fraction, okay? Yeah, we will, consider them, okay, when we do differentiations, but entirely this is what? multiplication. We have to use product rule, okay? How about this question B? Which rule are we going to use? Product rule or quotient rule to do the derivative? Product rule, right? Product, okay? Product. How about question C and question D? Is this a fraction? Yes. So when we differentiate this, we have to use what? Quotient rule. How about this one? Quotient rule, okay? So among the 4 problems, I'll need you to do 2 of them, and then you do the other as practice, okay? All right, so I'm going to show you question B and question D, okay? Then you try the other 2 practice, okay, in group. So question B, differentiate function y. If y equals e to the p's power times by p plus p times square root of p. So what is the independent variable in this question? Is it x? No, it is what? P, right? It's a p. Dependent variable is y, right? Y is a function of p. Okay, so how to compute y prime? If this is a product, yes or no? Yes. So we can consider this function is what? F. How about this function? G, right?
Sure. Everyone's saying that's both f and f prime.
F. Oh, yeah. Well, this is y, right? Yeah. This is y.
No, I'm saying the section you've circled and labeled f, it's also f prime.
Well, the entire is g.
No, the other section you circled, yeah, because e to the p would differentiated would just be e to the p.
Yes.
So the section you've circled and labeled f is also f prime. Since it's the differentiation of.
Yes, you're right. It's also f prime, yes. But so far, from the original function, okay, we circle them, this is f, this is g. So when we differentiate y, we're doing what? F times g prime, right? So this, by using the product, will give us what? Differentiate f times by g plus differentiate g times by what? F. Then we're going to differentiate this f and g respectively, and then using the formula, okay? So what is f prime? What is e to the p? It's derivative with respect to p. Just now, Grant already said f prime equals what? E to the p. Times by g. What is g? P times p times square root of p. Yeah, p plus p times square root of p. Everybody? Alright, now plus f. What is f? E to the p, right? So how to differentiate g? P plus p times square root of p. So the derivative of p is what? 1. What is the derivative of p times square root of p? P times square root of p, can we rewrite it as p times by p to the 1/2, and we write it into one single power function? Yes, 3/2, right? So this is p to the 3/2. So now you know p times square root of p equals p to the 3/2. So what is the derivative of p to the 3/2? Power rule, right? 3/2 times p to the 3/2 minus 1 give us what? 1/2. What's p to the 1/2? Square root of p, right? Alright, now let's see whether we can simplify. Okay, we can simplify this thing or not. equal to p, this is what? P to the what? 3/2, right? I'm going to rewrite this as p to the 3/2. So we have e to the p's power times by p plus p to the 3/2 plus e to the p's power times 1 plus 3/2 p to the 1/2. So see this term and this term, what is this? Common factor, right? Common factor. So we can pull this common factor e to the p's power out, and then let's see what are the leftovers, okay? Now from these parentheses we should have what? P plus p to the 3/2, because p to the 3/2, the 3/2 is greater than 1. So I say p to the 3/2 plus p. This is from this. And we're going to add up this, right? Add up this. By using a decreasing of the power, this is 3/2 times p to the 1/2 plus what? 1. Right? Guys, do you see that? Okay. I will leave this answer here, okay? Or if someone wants to distribute, yes, you can. You can have e to the p times by this, plus e to the p times by p, plus e to the p times by this, plus e to the p times by 1. So, yes, you can, but I'm going to leave it here, okay? And there's no way we can simplify this further, okay? No like terms, nothing else, okay? Everybody clear about question B? Alright, so, yeah, later when we do the question C, this division, okay, you may, I would like to let you to practice in a quotient rule to do it. If you do not want to use a quotient rule to do it, you can do what? Split this fraction into what? 2 separate terms. Each term will be a power function, and then you can use what? Power rule to do it. You don't have to use quotient rule, okay? But you can also use quotient rule to double check, okay, to see whether you have the same answer or not. Now, let's try question D together. Differentiate this function f. If f is defined by x over x plus c over x. What is c? It's just a constant. Okay, so f prime of x equals, do you still remember quotient rule?
1.
Yes. This is f, this is g. So by using quotient rule, on the bottom we should have a g square, right? On the top, what do we do? Remember that? Differentiate what? F. What's x square? What is x derivative of itself? Yeah, times by g, which is entire bottom, x plus c over x, minus, keep the f, which is x, times by the derivative of g. Okay, so I'm going to rewrite it like x plus c over x derivative, because it is too complicated to write it in here. So I just say, oh, the derivative of x plus c over x. What do you think? Alright, now in the next line, we have 1 times by this, which is x plus c over x minus x times by. Let's come to the derivative of this expression. X derivative is what? 1, right? Plus constant over x. This is another what? Sub what? Fraction, right? So this is f, this is g for us now, right? So use quotient rule again. Okay. If you don't want to use quotient rule, what's the other way? Easy way.
It's not a zero?
C over x can be written by c times by x to the negative 1's power. So you can use power rule to do it. Okay, but this is, I would say, x plus c to the x to negative 1's still derivative, okay? This is just rewritten from here to here. And then still we divide by x plus c over x squared. Everybody, are we on the same page?
Why wouldn't, I know it's probably a silly question, but why wouldn't the c turn into a 0 if you're taking the derivative of it?
Because only c itself's derivative equals 0. But if c is multiplied by the other function involving x, the derivative of c times by x is not 0 anymore. Okay, remember the c, c times by a function's derivative equals c times by the derivative of the function. Remember this?
Yes.
Okay, so c times by 1 over x, okay, we have to compute what? The derivative of x to the negative 1's power, it's derivative. Alright. On the bottom, we have x plus c over x squared. On the top, let's see what we have, okay? X plus c over x minus x times. Now we come to the derivative. What is derivative of x? 1 plus c times x to the negative 1's power differentiation. What should we get? Negative 1 times by c, right? c x to the negative 1 minus 1, negative 2. Equals x plus c over x squared. On the top we have x plus c over x. Okay, well here x times by the parentheses. Can we distribute the x? Yes. Okay, so negative x times 1, negative x. Negative x times by negative c times e, x to the negative square. Negative, negative become what? Positive. Okay, c is a constant c. What's x times by x to negative square, negative 2? Multiply x by x to the negative 1. Okay, which is what? C over x, right? C over x. Well, let's talk about it in the next, next line, okay? So now let's simplify the top. X is cancelled. We have a c over x plus what? C over x, right? So because c times by x negative 1 is c over x. So it's 2c over x on the top, right? So actually on the top, we should have a 2c over x divided by what? X plus c over x what? Square, right? So 2c over x divided by x plus c over x square, we can rewrite this as what? 2c over x divided by this, right? Divide by that. So 2c over x divided by this is simply multiplied by 1 over this, right? So 2c times 1 give us what? 2c. And then x times by this is going to be on our bottom, which is x times by x plus c over x square. Okay, we can solve it at here for this question. This is not an easy question because See, on the bottom, we have x plus c over x, and then we use the quotient rule, right? Square the bottom. Then we differentiate the top times by the denominator, minus the denominator's derivative times by numerator. And then we, what? Simplify, right? Simplify. And even in this part, okay, we have to do another, like power rule, another power rule. Or some of you guys may prefer to use what? A quotient rule here as well. Okay, either power rule, you rewrite it as a power function and then power rule, or you can do this part by using another power quotient rule. Okay, either way. So eventually the answer is negative c times x to the negative 2's power.
Can
Okay.
you show us how you do that using the quotient rule?
Yes, I was about to do it, and then you told me, oh wait a minute. so c, I'm going to use a different color of the pen. Okay. C over x derivative by using the quotient rule. Simon, how? What is f and g now?
Well, g is x.
G is x, right? So g squared on the bottom is x squared, right?
Right.
On the top, we're going to differentiate the numerator, which is c. Constant derivative is 0 times by x, right? 0 minus. Keep the numerator c. What is the derivative of x? 1, right?
Right.
So eventually, it should be 0 minus c, which is negative c over what? X squared, right? And let's look at if we're using the power rule, negative c times by x to the what? Negative square. Is this the same as this? Are they the same?
They are. But
They are.
where the negative go?
Because 1 over x squared give us what? X to negative 2, right?
Right. I'm talking about the negative in front of the c.
Negative in front of the c. It is here. 0 minus c times 1 is c, right?
Yeah.
0 minus c is negative c. And you see?
Yeah.
Are they the same? Yes, they are. So either you do it this way, or you can use another quotient rule, and we can always get the same answer. See? So c over x derivative equals negative c times by x to the negative 2's power. Anyone else? Alright, so I will give you, okay, we have another like 10 minutes or something, okay? I'm going to let you guys try the other questions, okay? Question A and C in group, okay? And then we'll talk about these two problems together, okay?